Here we have a SAT math question. So here we have a system of two linear equations in standard form. That is, we have X term and Y term on the left side and constant on the right side in each of the two equations in the given system. If the system of equations above has only one solution, which of the following could be the values of A and B? Okay, before we start solving this problem, what we can do is we can consider some stuff on solution of the system of two linear equations. Okay, now let me consider a system of two linear equations in standard form, that is a1x positive b1y equals to c1, and the other linear equation is a2x positive b2y equals to c2. So here in the given system of two linear equations, each equation is in standard form. Standard form means like having the x term and y term on the left side of the equation and constant on the right side. In both the equations, I have both x term and y term on the left side and constant on the right side. Okay, now I'm going to consider two cases over here. Let me write the first case. In the first case, what I consider is I am saying that the coefficients of x are equal, that is a1 and a2 are equal, and also I am saying that the coefficients of y are equal, that is b1 equals to b2, and also the constant terms are equal, that is c1 equals to c2. Okay, so when we have a system of two linear equations in standard form, if the coefficients of x are equal, coefficients of y are equal, and the constant terms are also equal, then we can say the given system has infinitely many solutions. Let me write the stuff over here. Infinitely many solutions. Okay, let me finish writing. Okay, so 1 second. Yeah, okay, so in this case the given system has infinitely many solutions. Now let me consider case 2. So in case 2, I am saying that the coefficients of x are equal, that is a1 and a2 are equal, and also I am saying that the coefficients of y are equal, that is b1 equals to b2. I am saying that constant terms c1 and c2 are not equal. So this is one which is different from the first case. In the first case, c1 and c2 are equal, but in the second case the constant terms are not equal. In this situation, the given system has no solution. So these are the two cases we consider for the given system of two linear equations we have in standard form. Okay, apart from these two cases, in all other cases, we'll have only one solution for the given system. So there are three options. One is the given system will have infinitely many solutions. The second one, the given system has no solution. And the third one is the given system has only one solution. So here I have given the two cases for infinitely many solutions and no solutions. And so except these two cases, if we get any other case, then we have to say the given system has only one solution. Okay, so here our information says the given system over here has only one solution, so that we have to find the values of the constants a and b. So for that we have to check the given answer choices one by one. Okay, now let me check answer choice a, that is I am going to take a equals to 1 and b equals to 3. Okay, now let me write the first equation in the given system as it is 2x positive 6y equals to 5. Okay, in the second equation I'm going to plug in the values that we have in answer choice a, that is a equals to 1, lowercase a equals to 1, lowercase b equals to 3. So when I plug in a equals to 1, it will become 1x. 1x is nothing but just x. When I plug in b equals to 3 over here, so it will become positive 3y, and on the right side we have 7. That can be taken as it is. Okay, now when I look at the first equation, so the coefficient of x and the coefficient of y, that is 2 and 6, both of them have the greatest common divisor 2. Since both the coefficient of x and coefficient of y have the greatest common divisor 2, we can divide each term of the first equation by 2. Okay, now let me do it. When I divide the first term 2x by 2, that is 2x over 2. So this 2 will cancel, we just get x. When I divide the first term 2x by 2, and when I divide the second term 6y by 2, what will happen? So 2 goes into 2 one time, 2 goes into 6 3 times. So when I divide 6y by 2, I'm getting 3y equals to, when I divide this 5 by 2, 5 over 2, or it is 2.5. I'm writing the second equation as it is because we don't have any greatest common divisor for the coefficient of x and y over here. So we cannot do any simplification in this one. We can write this one as it is. So we get x positive 3y equals to 7. Okay, here when I look at the system over here, the coefficient of x over here is 1 in the first equation. In the second equation also, the coefficient of x is 1. The coefficients of x are same, that is a1 equals to a2. And the coefficients of y are also same, that is b1 equals to b2. But the constant terms on the right side are not same, that is c1 is not equal to C2. So when I look at the stuff over here, it comes under the case 2. That means when I take a equals to 1 and b equals to 3, the given system has no solution, because A1 equals to A2, B1 equals to B2, and C1 is not equal to C2. It comes under the concept of case 2. There is no solution. So, but according to the information we have over here, the system must have only one solution. But when I use the values of this A and B, that is A equals to 1 and B equals to 3, the given system has no solution. So what we can do is we can reject option A. Okay, now let me cross out A because option A is incorrect. Now I'm going to verify option B. That is, in the second equation over here, I'm going to plug in A equals to 2 and B equals to 6. So let me do it. When I plug in A equals to 2, it will become 2x, and when I plug in B equals to 6 over here, it will become positive 6y equals to 7. Okay, here we have the same coefficients for y and same coefficients for x, but the constant terms are different. Again, it comes under the case 2. That means that the system over here has no solution. That is, when I use A equals to 2 and B equals to 6, the given system has no solution. But according to the information, this given system must have only one solution. So since the values of A and B in our answer choice B has given no solution for the given system, we can reject option B as well. Okay, now let's verify option C. Okay, that is we have to plug in A equals to 3 and B equals to 8. So let me write the first equation as it is. That is 2x positive 6y equals to 5. Now I am going to plug in A equals to 3 and B equals to 8. So when I do so, I'm getting 3x positive 8y equals to 7. So the same thing what I did earlier. So here I'm going to divide each term of the first equation by 2. So because the coefficient of x and coefficient of y have the greatest common divisor 2. When I divide 2x by 2, I'm just getting x. When I divide this 6y by 2, I'm getting 3y equals to. When I divide this 5 by 2, I'm getting 2.5. Okay, now here we don't have any greatest common divisor for 3 and 8. So what we can do is we can write this equation as it is. That is 3x positive 8y equals to 7. So here look at the coefficients of x in both the equations. So here we have 1, here we have 3. They are not same. Here the coefficient of x is y, coefficient of y is 8. So the coefficients of y are also not same. So the system we have over here does not come under the case 1, under case 2 as well. Since this is a case other than the case 1 and case 2 I have explained over here, so definitely this system will have only one solution, because I said already, so like apart from these two cases, if I get any other case, so then we have to decide the system has only one solution. So the system of equations we have over here for the values of A equals to 3 and B equals to 8. So the system does not come under case 1 and also case 2. So clearly when I take A equals to 3 and B equals to 8, the given system has only one solution. So option C is correct. Anyways, we can verify option D as well. Okay, so for that we have to plug in A equals to 4 and B equals to 12 in the second equation. So when I do so, I'm getting 4x positive 12y equals to 7. Okay, so here the same thing, the coefficient of x in the first equation, coefficient of y in the same first equation have the greatest common divisor 2. We can divide everything by 2, then I'm getting x positive 3y equals to 2.5. Okay, now so here when I look at the coefficient of x and coefficient of y in the second equation, both of them have the greatest common divisor 4. So we can divide each term of the second equation by 4. When I divide this 4x by 4, I'm getting just x. When I divide this 12x by 4, I'm getting 3y. So now let me divide 7 by 4. So when I divide 7 by 4, I'm getting 1.75. So here when I use the values of A equals to 4 and B equals to 12 in option D, so I'm getting the same coefficient for x and same coefficient for y, but the constant terms are different. So when I use the values of A and B in answer choice D, so the system of equation, linear equations we have over here comes under the case 2. So that is this system, the system we have over here has no solution because it comes under case 2. So that is A1 equals to A2, B1 equals to B2, but C1 and C2 are not equal. So since we get no solution when I use A equals to 4 and B equals to 1 in answer choice D, so it does not satisfy the condition given in the question. That is only one solution. So we can reject option D as well. So only in answer choice C, that is the value we have for A, that is 3, and the value we have for B, that is 8. When I plug it into the given system, it gives only one solution. So the correct answer choice for this question is answer choice C.